So welcome everybody to this community call of the Internet of Production Alliance, and the first in the fireside chat format where we just speak to one guest speaker who has a lot to say and explore topics relevant to Internet of Production, decentralized manufacturing. So my very first question to our speaker, Alex Kimber, is going to be, who are you? Can you introduce yourselves to us, please?
Start off with the toughest questions, the most existential. My name's Alex. I'm a product industrial designer. My design studio is Alex Kimber Design, and I've been involved with the Internet of Production through this electronic components research project, which we'll dive a lot deeper into. But my focus within design is about trying to support and advocate for this distributed model of design. So trying to decentralize design, empower participatory models, localize manufacture, and so on.
That's good to hear. We'll dive more into the research itself in a moment. I did want to open the discussion and give it a little bit of context, which is why did we conduct or order research on electronic components at the Internet of Production Alliance. Some of you may know that this is actually the first piece of research that was started at the same time as the Alliance was founded. So the same people in the room that came together to then create the Internet of Production Alliance, among them were a group of people who said, well, some of what we need to enable an Internet of Production and distributed manufacturing is enabling it to be easier to work with electronic components. And that is because in most countries of the world, electronic components themselves are very difficult to access. This means that what you can design and produce there locally is then of the simpler type, because it's with electronic components that you can start looking at a lot more complex designs. So the value that can derive from decentralized manufacturing, if you take out electronic components, is a lot more limited. And to have a thriving Internet of Production, you would need people to have access to electronic components everywhere so that they can produce anything anywhere, which is sort of the vision behind the Internet of Production Alliance. If you want to be able to create products locally rather than consume the end of the supply chain on site, then we're going to need to look at this question of electronic components. Alongside this, electronic components is currently an area of research and an area of focus on in like, I would say, sister movements or sister thoughts that have to do with the circular economy and the repair movements and the right that then lead to the right to repair movement. And thanks to those, electronic components are already very standardized. So as a first topic to explore, it seemed to make sense to start looking at how do we enable distributed manufacturing around standardization of the materials and the components that go in distributed manufacturing, by starting with electronic components, by starting with a field where standardization had already begun, to see what was out there, what might be the gaps, what the Internet of Production Alliance might contribute to the topic. So that was sort of the why. And then there was an opportunity side, which was that the people that were in the room then, and this is where I can cite Caspar Emanuel, who was the instigator of this research, they had the expertise, they had the idea, and this is part of how the Internet of Production Alliance function. Like, we want to support members of the Alliance who have a field of interest that has to do with an Internet of Production, and we're able to identify funding, provide secretariat resources to enable research of this kind to be conducted. So if you have any other similar ideas, do come to us with those ideas so we can work together on enabling an Internet of Production to come to being. That was for the context, and that was the part where I think I speak the most. That was the initial idea. Alex, can you tell us how you went about conducting this research?
Sure. So a small team of us were gathered through Casper, as you mentioned, and KitSpace. We had a pretty tight-knit team representing electronic engineers, myself as a designer, some UX designers. I can see Kenza is in this call, who was in the team. So yeah, there was a tight-knit team of us who brought both the technical expertise, as you mentioned, but also a degree of understanding of methods and process. So talking of which, we took a qualitative approach. So we interviewed a number of participants across different stakeholder groups who are relevant to designing with electronic components and sourcing electronic components and so on. So those stakeholder groups include repair activists, people who are active in the rights of repair movement, engineers, people who are relevant in the design and technical aspects of making products, repair technicians, the people who are more downstream fixing these products, software developers, standards experts, and supply chain experts. So by interviewing these stakeholders, who we also were careful to ensure that they came from a range of geographical locations as well. So we tried to get as wide a spread as possible. We were able to extract insights and key takeaways from the interview data to formulate the key factors that would be necessary for an open standard for the repairability of electronic components. Ultimately, we interviewed 40 people, and the process that we took was to interview them in a very informal kind of way, just to get their view, get their position, not to kind of impose one particular template of questions on them. And from that, assess what the key takeaways are, what the learnings are, and analyze those key takeaways to produce a report, which is available on the forum, in the link, in the description. I'm sure the report will be made available.
Yep, I have just copied it into the chat. And it's also on the notepad towards the top. We won't bore you by going through the entire report, I hope. So Alex, my next question will be, in a nutshell, in like the most interesting nutshell possible, what are those key findings? And I'm hoping maybe you could share some surprises that came up during the research, or maybe some more striking examples, conversations you had.
Yeah, so ultimately it's about results, right? The goal here is to try and produce an end product. So how do the findings that we came across lead towards a better standard? The sort of headlines that we identified were design process. So how is it that designers and engineers consider the requirements for the design? How do engineers consider repairability upstream? We talked about supply chain, so the accessibility of replacement components, particularly in developing contexts. An interesting note that we came across there is that in certain African contexts, you have very informal supply chains. There might be someone that you know who's a sort of informal means of getting the spare parts that you need, but the spare parts that you need might not necessarily be the parts that the designer specified. So an aspect of the repairability standard might be identifying alternative spare parts. Documentation is key. Repair documentation, exploded diagrams, schematics, all this kind of stuff. An interesting aspect from our conversation on that was not just about the technical documentation, but actually documenting purpose, right? What was this component for? What was this design's function? What was this sub-circuit's function? So that perhaps a repairer might not need to replace that specific component, but repair the task of that circuit. Barriers, there's a number of barriers to design to repair, largely cultural, largely economic. Engineers and companies are not incentivized to spend a long time in development focusing on repairability. One aspect of that is the fact that once the product has been sold, the kind of economic incentive is over, right? Once the product's handed over into the customer's hands, the company is not making any more money from investing time and energy in repairing that product. It's almost like an externality cost, considering design for repair. We wanted to connect repairability to education, because a lot of the engineers were talking about how they'd felt let down by their education, that they're not really trained to repair, not just in terms of design for repair, but repairability itself. A lot of engineers are not getting practically involved with fixing things, and therefore not having an intuitive sense of how it is to design more repairably. But I think the most interesting and probably the most surprising point for me was this idea of repairability being an opportunity for strategy, right? Turning the economic model on its head. So instead of saying design for repairability is a kind of downstream externality, you could use repair data upstream as a means of diagnostics and problem solving, as an R&D strategy. So if standards and data analysis could connect downstream repair data, which parts are failing, which components are failing, how long did they last, what tools are needed, in which areas are these things failing, and feeding that data back up into design intelligence for design teams to then feed back into their R&D and connect that with repairability, then you're turning the economic incentive on its head. Then you're saying this is an upstream, better design resource for durability and longevity and so on, and connecting repair with that, rather than seeing it as a kind of economic problem down the other end of the stream. So yeah, that was one of the most surprising revelations. I think one thing that we kind of came up against in the conversations that we had was that the larger scale problem wasn't so much a technical one, it was almost like an economic one, right? Where on several occasions, either with participants or among ourselves, we were talking about, the problem here is not standardization, it's capitalism. We need to overturn consumerism itself, which makes the task quite daunting. But I think there are interesting ways of perhaps rejigging the incentives for repairability. That was the most kind of insightful revelation from this research.
Oh, thanks. So thank you, first of all, for giving examples for each of those 4 fields of exploration. So that's what I hear from what you're saying, right? That this scoping exercise of open interviews leads to 4 avenues of further exploration that would enable us to find what it is that could be standardized, that would be best in service of repairability in the context of electronic components. So repairing electronic components within a design, or repairing a design that's purely made of electronic components. There's a question of supply chain, there's a question of documentation, and what kind or what quality of documentation. There's the last aspect that you were talking about in terms of how you can, where it is that you're placing the repairability. You were talking about the design process. Could you give me a little bit more example on that one? I feel it's the one that you dug least in. Might be because you know the least of it. I might be tricking you here. I'm not sure. I hope not.
So as a product and industrial designer, this project's been a pretty interesting learning curve in terms of the electronics design. So if there are any electrical engineers in here that can sense that I'm getting my terms wrong, then do forgive me. But one very specific example of how design process can be intervened is this idea of using design rules. So when you're designing your PCB, there will be design rule checks to ensure that the physical dimensions of your components and the spacing and layout of your PCB is accurate so that it's manufacturable, right? So there's a kind of requirement programmed into how it is the PCBs are laid out, and that helps with the design. But if you could set up the design rule checks to account for, let's say, the spacing in between the components, such that they were easier to access and easier to remove with the tools that are readily available, and you program that into how it is that PCBs are designed from the get-go, then you're kind of factoring in repairability through your design process, through your workflow. And that could either be a software intervention, like I said, with design rule checks, or it could be a kind of process intervention, like ensuring the requirements for your design account for repairability.
I don't know how to say that's fascinating without sounding like I'm just saying it, but it is fascinating. I'm pretty sure it's not what the team thought they would come up with to start with. So I'm just really curious about how it felt to be hearing all of these different inputs. But that's actually not my next question. My next question is a bit more, what do we do next? Like, we have these 4 possible avenues of exploration that are insights from conversations. That's a scoping exercise of like, okay, if we were to standardize something around electronic components, these could be the elements that need to be standardized or would have an impact if they were standardized. So where do we go from now to something that actually does put this in place? How would we go about doing that?
Sure. So the report that we wrote gave kind of 4 next steps. They include prototyping the suggestions that we made. So starting to build models and prototypes for each of those suggestions and using them to kind of test the viability in principle. Community engagement, so continuing with engaging with the participants that we've gathered a community around, and also opening up to forums in order to gather feedback on the prototypes and iterate those prototypes forward. We need to develop success criteria, so really making an assessment based on the findings from the research, the feedback from the community, and kind of itemizing what are the determining factors, what are the specific and measurable criteria, so that we can select down which of the kind of ideas are going to work best, are going to be most applicable, and then applying those requirements to the prototypes to narrow them down. So using that as a filter to then get down to a final solution and continue that prototyping, continue that iteration, and hopefully launching some kind of technical standard with the community. Yeah, so I think that's a pretty general 4-step process, you could say, as a suggestion for next steps.
Thanks, Alex. Before I ask any more questions, I would like to open up now the floor to anyone who might have questions. And you can, considering the amount of people you are welcome to just unmute yourself and ask your questions directly. Part of what I'm interested in the conversation that we're going to have now for the next 10 minutes, it can go on longer if there are more questions, is do we have right here in this call or in the wider community of the people you interviewed, that community that could do some of the work that you just described so that we were to take this forward? I know that these 4 steps that you describe for the exploration of these 4 avenues of further research and development, they're already on our fundraising wish list. But beyond the question of having the money to do it, there is having a community of people who are practitioners or experts of the field who would be interested in participating in it. So that's what I kind of questions I might ask to everyone here. If anybody wants to react to that, or to ask questions to Alex or share comments, now is your time to unmute yourself. Harris, if you want to go first,
Yeah.
and then in order, I've got Andrew and Sarah, and then Max.
Okay. So a couple of things. First, for the community and people, I know that I might be in the last couple of days, I might be spreading promises to many people, but I may still have free time, so I would volunteer to, if there's anything I can do, I might still have some time. And the second thing is what I put in the notes, which is irrespective of capitalism, there's another sort of, maybe I labeled it as a political question, but it might also be framed as a sort of international relations question, which I want to test if it's really relevant, which is electronic components being churned out massively within certain countries, and then you get sanctions, you get trade wars, you get all of these things. And I got the impression through Alex's talk that we could seriously mess this system up, basically. So we are doing some important work, but B, some work that might go against very strong components or elements of the world order or something, let's put it that way. And I wanted to see, is this really what's going on, or am I just imagining things? And whether we need to think about these things or not. And I gave him the example in the notes of China, like of the US and China, the US and Holland, I think, blocking some chips or something. So this is a political, like an international relations and political game with the chips, that we're coming to gate crash and say decentralization, everybody, democratization of production. There's very big issues. Okay, I'll stop there so that people ask questions.
Alex, would you like to answer that?
Well, viva la revolution, comrades. We, without kind of straying too far from my, let's say, professional domain, I think there is a political component to this, definitely. I think, yeah, trying to enable distributed production and sort of localized supply chains, it inevitably interfaces with kind of broad global trends and kind of, I kind of foresee distributed production as being a more robust means of getting things made and getting materials to the people who need them, rather than these kind of larger linear models. I don't think I'm particularly qualified or well researched to talk about the kind of, let's say, what would happen if China attacked Taiwan and how that would affect semiconductor supply chains. I don't think I'm going to delve too deep into that. But from a strictly engineering point, I think you're right in that you can't escape the political aspect. You can't escape the geopolitical aspect because it directly impacts your material supply chain. And so there has to be at least an understanding of that perspective and an understanding of the fragility of linear supply chains and how distributed supply chains, although maybe less efficient per unit, is ultimately a more efficient system. But it's a very curious point.
We might return to this conversation when we keep the conversation open later, but I do want to let in 2-3 questions more. So I believe Andrew's hand is not raised anymore, but do you still want to say something, Andrew?
I just want to say thank you very much for your work, and I think the enormous scope of the challenge here is, the fact that we found something where we can immediately contribute is really helpful. So thank you for that. I think the fact that there are often so many electronic component manufacturers, that there's only a few sort of major brand names, less than 100 perhaps, for different types of electronic components. Obviously, there's all sorts of assemblies as well, but for the basic components, there's only a few different manufacturers. That sort of lends itself to being able to, it's a very standardized industry anyway, and Barbara was talking about this before. So do you think those manufacturers would be interested in being part of this community as well, the community that Barbara was asking about? Or do you think that this is essentially something where it's a user demand? We need this to happen, therefore if we start doing it, the companies will just follow where the market is, sort of thing. I'm curious to know a little bit, because part of my job at the Alliance, the Internet of Production, is to find new members of the community that we can bring in, and I'm not shy to be ambitious about getting some big electronics components manufacturers on board.
Well, firstly, thank you for welcoming me on board with the team and the project. I think with a lot of these kind of changes, I don't think it has to be exclusively bottom-up, grassroots, or top-down institutional. I think there's definitely a two-pronged approach, and I think with distributed as a paradigm for getting things made, it's not the enemy of standardization. I think it's about identifying which components and which functions are practically standardized and which components and which products are more suitably made locally or made customizable and so on. So, I think components like bolts and resistors and capacitors and so on, they lend themselves to be standardized. So I think breaking up those few large manufacturers of standardized components probably doesn't help distributed supply chains. And so I think that the pitch to those larger organizations would be, look, this is, at least in principle, a more robust supply chain model, given that we live in a far more kind of turbulent, let's go back to the geopolitical sort of context, a much more turbulent environment. You can still get your product out to customers, to people who need it, to suppliers, more reliably, more consistently through a kind of broader range of different supply chain models. So I think there's a pitch to be made upstream to the new manufacturers that you mentioned. I don't think it's a combative thing. I think you can definitely work with those institutions.
Well, thank you, and I think that's a sensible approach. Part of what I've also been thinking about in terms of building internet of production is making sure that in many countries we can find ways to enable businesses that do the importing of electronic components. And it's not just for the university markets or for teaching or for whatever, but actually for makers and for producers. Because what happens at the moment in many developing countries is that one person figures out how to do it, and then everyone else orders from that one person to these devices, or people bring them in on the back. And if I can show off for a sec, I'm at the State of Open conference in London. And talking of geopolitics, over in that building over there, right now is President Zelensky making a speech to Parliament. And part of the whole reason that we wanted to do something around electronics components is that there are makers in Ukraine right now, with the Tolokar project and many others, trying to figure out how to make things like basic medical devices that call for electronic components to be included. So the ease of recovery and replaceability and repair is something that's very much on their minds. And yeah, so there's a number of ways that we can see the benefits of what you propose. And yeah, thank you.
And Max, the microphone goes to you.
Thanks. Just wanted to check, Sarah, I think Sarah had a hand raised before.
I'm good, thanks.
Yeah.
I lowered it in favor of you going.
Oh, thank you. Yeah, so thanks again, Alex, for presenting your work and summarizing it so well. The question I have is sort of around this. I guess it's related to the incentive structure, which I think is a very interesting aspect of looking at the different incentives and how they can shape this this whole conversation, and sort of this idea of, I guess, making repairability more synonymous with durability, and that it is, I think, and how. But I think one of the key questions, and I'm just wondering whether you think this is an area for further research here, which is about the consumer side of that incentive structure, and whether consumers are more would be willing to pay more. Again, if we think about it as a question of durability, where, you know, if repairable products are, you know, even if they're at the higher price point, and whether, if that is true, then that would incentivize sort of further upstream the manufacturers to make those essentially higher quality products in terms of durability and repairability. And I'm thinking here, you know, the parallels with the fashion industry come to mind in terms of sort of fast fashion versus sort of, you know, buying something that'll last you for a long time, and what we can learn perhaps from what's been happening in those kinds of industries and how it might be applicable to these. And I just want to link in another sort of thought or question around this idea and of conversation I was having recently around sort of this idea of high fidelity and low fidelity, and whether, when you were in the context of this sort of repairability, you know, if people knew that they had the option of, you know, perhaps when you're talking about this sort of taxonomy of sort of what can be replaced with what, you know, saying, look, you can replace this, but you do have a sort of a lower fidelity option. And I'm thinking, when you're talking about supply chains, one of the interesting areas of research is, which is, I think, extremely underfunded for many reasons right now, is in looking, for example, at chip manufacturing. And there are ways, instead of having to have these multi-billion-dollar fab facilities, you know, you can create chip fabs that are orders of magnitude cheaper, but they produce lower quality in the sense, you know, they won't have as many components on them, they might not be as fast, but they can get certain jobs done quite well. So I know I've sort of tried to weave two questions into one there, but hoping you can address that. Thanks.
No, it's very very relevant, trying to connect the incentives with the repairability, design repairability strategy, because, you know, money talks. It's kind of a shame to think about that. I think two things spring to mind when you reference kind of comparing with the fast versus slow fashion industry. I think another pertinent example, which is worth benchmarking against, is the French repairability index. This is something that a lot of participants referenced in the research, and I think is, you know, an excellent initiative. There's a critique about the kind of effectiveness of it, how when you delve deep into the specifics of the criteria of how it is that the index is calculated, there are ways and means that manufacturers are kind of subverting the accuracy of the score. But aside from that, that seems like a continuous development thing. By and large, it's an appreciable index, and I think consumers, at least from what I understand, what's happening in France, appreciate the repairability index. And a conclusion that we came to in the report was that there could be a brand value, right? If you look at B Corp, if you look at eco-labeling, there could be a kind of brand value to repairability. So that probably interfaces with the Right to Repair campaign and all other kind of consumer awareness aspects in order to connect that with a marketing and commercial incentive for durability and repair. And then bringing that in with your kind of lo-fi, hi-fi paradigm, something that strikes me, this is maybe not founded in research, but it seems apparent that since the kind of 1950s, what do they call it? Planned obsolescence model, where you add a new kind of cosmetic feature to a product and you relaunch and you relaunch and you relaunch. 80% of the products that we still use today are fundamentally not much different from how they were 70 years ago. A toaster hasn't really changed apart from an LED and maybe a little control board, and maybe it's an Internet of Things product now. But there's a lot about the products that we use which are somewhat artificially made better quality. And so in terms of making things that kind of satisfy a primary function or a simple function, we're very good at making that quite cheaply already. So connecting that with standardized components, connecting that with standardized sub-circuit designs and so on, and kind of being able to say, yeah, we can make a whole range of essentially effective products which don't have all the bells and whistles, but will do 80-90% of what it is you want them to do incredibly cheaply, by rethinking the model through which we're making design. I don't know if that sort of directly pinpoints the answer that you're looking for your question, but those are the thoughts that came to mind anyway.
Sarah, your hand is up again. The microphone is yours. I just want to say that we'll take one more question after that, or open up for continued thoughts on the previous questions. So if you have a burning thought, raise your hand right now. Be the first. Go, Sarah.
I'll keep mine brief. I just wanted to bring attention to, so far as next steps are concerned, there's a lot I could add to this conversation regarding incentivization, which is huge. And it goes back to your, mentioning, Alex, of it's actually capitalism we're talking about here, not a particular standard. And to that end, in the notes document, rather than listing questions, I've listed several different contexts, one of which is David Franquesa, who is the CEO of Reuse, eReuse, and also, co-director of eReuse and CEO of UStudy, and is exploring these types of incentivization models, specifically in the context of electronic components and repair. Because I am very interested, and there have been a lot of conversations within the other standards we've been discussing about that low fidelity, high fidelity, and especially when it comes to what types of materials are being used for the repairs, and the quality of said materials, and how that impacts the overall quality of the product, and how do you write that into any sort of specification? Should you write it into any sort of specification if there isn't any sort of quality assurance or certification tied to it? So In addition to David, there are a few others. There's the Obata Foundation, the Beneficial Bio folks, and of course the authors, many of whom we work with in other areas in the Alliance, that released the Distributed Manufacturing of Open Hardware report in November. And parts of that report speak to these issues, particularly as are mentioned in the electronic EC report on documentation, which is a big problem for all of us. And by problem, I mean there are many areas that we have identified as gaps that we want to improve. And it's very interesting to me to be engaging and reading all of these reports and seeing these thematic elements cutting across all. And that means there's a community that could be working on addressing this overarching problem. So that's where I'll stop.
Perhaps I can firstly thank you so much for sharing all the references in the open pad. How would you describe this kind of text document that's going? Anyway, thank you for sharing all the resources.
Pad, that way they get a bit of advertisement as well.
Yeah.
The open of notepads.
I think I can connect the sort of two broad points that you make with a perspective that I have about distributed design, which is there's a kind of paradox in that by relinquishing a degree of control over the process and the final outcome of the design, you're having to kind of engage in trust with the person who's making it and the person who's using it. So let's say, for example, if I design a shelf and I have complete control over the supply chain and the materials and so on, and I have a warranty on my product and it's totally closed source, if that shelf then falls on a child and kills them, the liability is pretty clear. But if I have an open source design and someone else makes it that I'm not aware of, and they use lower quality materials and lower different processes that I didn't specify, where's the degree of responsibility that the designer has for safety, conformity, quality, all that kind of thing? So there's a definite paradox here between how much should I specify and how much should I entrust the community and the makers and the supply chain and so on distributively to interpret my design intention kind of accurately and with the right scruples. So, you know, I think there's a fundamental question between the information necessary to make things and the control and the degree of control that the designer relinquishes over that information, if that makes sense. Perhaps I've abstracted that a bit too far, but I think what you were talking about kind of sprung to mind, this kind of paradox that we have.
Yeah, I don't think that it, no, I don't think that you took it too far at all. And one of the things that came up, believe it or not, that I see as being very similar, of course, goes back to libraries where, you know, you're talking about copyright law and whose responsibility is it to enforce it? And looking at the organization, in this case, would be in parallel to the person who was the original designer, specifies like this is the criteria by which I'm releasing this content. The onus is upon you to take that responsibility, therefore, you know, handing off the liability to the end user, essentially. But what does that look like in practice? You know, what does that look like in litigation? That's the big unknown and the kind of, you know, frightening part for all of this. But I do understand with the abstraction, absolutely.
Andrew, you have taken the last question spot or comment spot. Go ahead.
Thanks. Yeah, on that quickly on that point, I was just attending a talk here by Andrew Katz, who's worked on a lot of open hardware legal issues, and that question of where the liability lies is not something that has yet been tested in the court. So I think really, it's something we have to think about, but I wouldn't want it to be a barrier to, because I think there's a lot of the engineering groups that I've been working with are very worried about the quality of their work all the time. And not because that they are worried about getting sued or anything, it's because they're worried about causing harm. And so that's one, you know, we're not there yet, but we will see. Alex, what would you suggest, if anything, that the IOP Alliance, the International Production Alliance, does differently next time we commission somebody to work on an open standard for materials or components? Because we could be doing plywood, we could be doing optical components, we could be doing plumbing equipment, we could be doing hydraulics, like what, I mean, there's all sorts of potential standards for things. You know, we could be doing different, there are plenty of standards around different types of 3D printer materials already, and none of them are really particularly collaborative. What do you think we should do next time we commission work into a standard around materials or components?
Great. I think there's two answers that I have to your sort of next time question. One sort of more operation and one about the sort of product subject category. So as a designer, I think I'm very much process driven and process aware. So I quite, and this is maybe more of a personal preference than an actual sort of material
sure.
feedback, but I think in terms of operation of managing a research project, I think it's nice to have kind of clearly delimited goals, clearly delimited stage gates, and manage things maybe more overtly. But that's me just being, you know, I'm always making Gantt charts and things like that. So maybe that's more of my just take on how things are organized. In terms of product categories, it's hard to say. You're right. There's an absolute like plethora of kind of spaces where we could intervene in. The two areas that I think might be maybe most fruitful are perhaps a bit too big to bite off, but construction and agriculture, because I'm just thinking in terms of emissions.
Okay.
Construction has a terrible reputation just in terms of the materiality and the efficiency of recycling materials in construction. Doing something with aggregate materials, doing something with sourcing in construction, that could be a huge space for intervening with a sustainable supply chain. Similar with agriculture as well. But that might be pretty big though.
Thank you. And happily there's a lot of not sure about construction, but there's a lot of open source projects in the agriculture sector already, and a lot of reuse being encouraged in the construction sector. So that resonates. Thank you very much.
Right. Everyone, we are precisely at the top of the hour. Yay. So we're going to close the call. And if there are people who would like to continue to chat together because they're happy to be in the same call, you are very welcome. And I'm going to close the recording in a minute after I have said thank you very much, Alex, both for the work on the research piece, along with Kenza, who is here, Kaspar, Schack, and John, I hope I haven't forgotten anyone. Thank you for that, and thank you for speaking today and just going along with this experiment of what does it look to speak for an hour without PowerPoint slides. Congratulations, you did great. Thank you very much, everyone. I'm going to stop the recording.
Thank you very much.